and in this session we are going to have a DP-100 exam cram. So we'll get started. So my name is Jen Stirrup, and it's my pleasure to be your host here today for this Scale Me Up session. So the DP-100 exam covers a number of topics. Firstly, we look at how we set up an Azure Learning Workspace. We'll also look at how we can set up experiments and train models. We also examine how we can optimize and manage models, and then deploy and consume those models in a data science environment. So the first part of the section really is to cover the course content, and then this should help lead you towards a path as a successful career and effective data scientist. So before we get started with the content, let's try and understand better what we would like to see in the exam. Now, this is the exam syllabus right here, and you can see that the exam consists of a number of items. Now, the content for setting up an Azure Machine Learning Workspace accounts for between 30 and 35% of the whole exam. You'll also notice that this topic contains a number of subsections. So in the first instance, we can see the first item is to see how we create an Azure Machine Learning Workspace. That involves creating a machine learning workspace, configuring it, and also managing the data objects in the workspace, and also managing the compute experiment, its contexts. Another portion of the exam is on the topic of how to run experiments and train models. That accounts for a total of 25 to 30% of the total exam. To do that, we can create models using the Azure Machine Learning Designer, and we can run the training scripts for Azure Machine Learning Workspace. This topic also includes other subtopics, such as creating models using the Azure Machine Learning Designer, running training scripts, and how we can generate metrics from an experiment run. We also look to see how we can automate the model learning process too. So what is covered in the exam? The final section is all about optimizing and managing models, and that accounts for 20 to 25% of the whole exam. That also involves configuring some Azure components, such as how we can use hyperdrive to fix hyperparameters in order to make our models appear more accurate and also run faster. We also want to see how we can manage models. Now, for example, we can manage the model history. So first of all, before we get started with the demo, let's understand better what an Azure Machine Learning Workspace actually looks like. That involves a number of components. We can set up a workspace using the Azure Machine Learning Studio. So the first step that we need to do is to sign up to the Azure portal with an Azure account. Then we can create a resource, and then we can use the term machine learning in the search bar, and then we can create an option. So what we will do is we will have a look at how we can set up an Azure machine learning workspace, and we do that in the browser. So let's have a look at the browser here. So what we can do is go to Azure ML, and then we can have a search for that. So we don't have an Azure subscription, but let's say for a moment we just want to try it out. What we could do in the first instance is choose anonymous guest access, or we could sign in with a work or a school account, or a Microsoft account, such as a live account. So let's see if we can sign in. So what we're going to do is use the access, and we're going to sign up here. And we can use an 8-hour trial that you can see here. So this will set us up for an 8-hour free trial of the solution in Azure Machine Learning Studio. So let's have a quick whiz tour of Azure Machine Learning before we get started. You can see we have no experiments in here. We've also, when we go into the datasets, we can see we don't have any datasets. But we do have the opportunity to look at some samples. So we will use some of the sample datasets when we run through this particular example. Now, we don't have any trained models because we've just set up a brand new space. You can see we have got 8 hours remaining of our trial, and I have signed up as a guest. So what we can do first of all is we can use the new facility, and we can set up a sample, and this will help us to learn about Azure Machine Learning, and that will help when we are thinking about the exam. So what we could do is look at some of the samples, and these are a great way to get started when we are learning about Azure Machine Learning. So in preparation for the exam, please do make sure that you take time to go through these examples, and that will help you to prepare for the exam. What I'm going to do, however, is create a brand new blank experiment. So this is our Azure Machine Learning Studio experiment. And since we are using a guest account, we have got some Azure storage behind the scenes that will store our information temporarily while we use the sample access. So there are a number of saved datasets, and those are in the samples folder. So we can see there are plenty of examples in order to get started. The one that we are going to use is the adult census income binary set. If you're interested, you can see this dataset by clicking over here on the View Dataset item. And you can see this in CSV format. So before we get started, let's have a look at the data. So the file is just opening. So let's have a look. You can see in the very first row, these are the column headers. Now the thing we want to predict is the income column here. We want to understand if people earn above or below $50,000 a year. So we want to predict that characteristic. We want to predict their income levels based on their characteristics. So you can see different characteristics here. For example, we could work out whether they are male or female, for example. We could also look at things like the marital status, and we could also look at their working class as well. So there are plenty of characteristics here, and we can look at that and try to understand better if we are able to gauge someone's outcome dependent on their income and their other characteristics. Okay, so that's the data set that we are using. I'm going to pop that there. Okay. So now we know what our data set looks like. What we can do is examine it in more detail by looking at some additional features in Azure Machine Learning that will help us to understand the data a bit better. So when we look at the adult census income binary dataset, we want to understand better the characteristics of the data. We've seen the underlying dataset ourselves, so let's try and understand better more details of the data. For example, the descriptive statistics. So Azure Machine Learning has got the opportunity to summarize data. So we can drag and drop the summarize data module onto the canvas. The canvas is this grey square here, and we can use that in order to create in our experiment. So this will give us a view of the dataset, and it will help us to understand what we're looking for. So with any data science experiment, a good way to get started is to understand the summary of the data or the descriptive statistics. So Azure Machine Learning will do that for us. Now you've probably spotted how quick it is to run. So let's have a look and see what the descriptive statistics are for our dataset. So when we click on Summarize Data, you can see that we have an output here, and this is called the Visualize output. This will help us to understand better what our statistics look like. So we can see that we have 15 rows and 23 columns. We can see also that there are in total 32,561 rows. And we know that because that's the count of the age. So it looks like everybody who is present in the census dataset has their age, and there's no missing values counted here at all. So that tells us the number of rows is 32,561. What we do spot is that there is a missing value count here for the working class. And when we add together the missing value count and the count here, that adds up to 32,561. So that tells us more about the information because it tells us how many people we have in our census dataset. Now there's some interesting things in this data. For example, we can see the minimum age is 17. We can also see that the maximum age is 90. That looks to us like something is wrong with the data, because the census is supposed to cover working adults. So we certainly hope that people are not working in their 90s. So why don't we have another look? So now we've summarised our data, we might decide that we want to clip the values that are not relevant for this. Now, having people in their 90s who are working, that sounds that perhaps something is wrong with the data. So what we can do is we can search the experiment. We can type in the word clip, and then we can put clip in here. What that's going to do is going to remove rows where people are over 90 are 90 years old. We may want to restrict our dataset to people who are 75 years and below. So now we have connected the dataset to the clip values, and we need to scroll along and we'll look for our properties. We just tidy up the screen so it looks a bit better. So what we can see here is we need to select the column that we would like to clip the values for. So we want to include, we're going to begin with all columns. And what we could do here is include all of our column names in here. But what we want to do is launch the selector, and we want to begin with all columns, and we can exclude a couple as well. What we could do is exclude a particular column that we don't want used. So one column that we don't want is the column called final weight. That's specific to the census. So we don't need that particular column. So I'm going to exclude that one. So what we could do as well is in the columns is what we could do is just say we want to see where the age is over 95, is over 75. So the constant value is number 75. So we'll just use that one. So I'm going to run the experiment again. And this time, when we click the values, we will probably see that there are less values in here. So we've spotted there's an error in here. So let's see the results. We could open this in a new notebook if you like. But what we could do is we could start to look at different ways that we can remove the data. So let's have a look at how we can look at the metadata of the column. So let's look at the metadata first. So now we're going to connect the dataset to the Edit Metadata module. And what that's going to do is we can start to include only the columns that we want. And then we can get rid of the final weight column. So we can get rid of that one. So that means the selected columns are here. If we want, we could also change data types in here. And we could also change column names in here as well. So that gives us a good start with our data. So what we can do then is we can think about splitting our data as well. And that would allow us to split our data into a training set and a test set. Oops. So what that's going to do, sorry, keeps going back. There. So that can split our data set into one or two types. It can split into a testing data set and a training data set. So to connect these two together, all we do is split the data on the canvas, and we connect up the edit metadata, and we add that to the canvas, and then we can actually use the output of the metadata as the input for the split data. So we could do it that way, or alternatively, what we can do is remove this from now and start to look at how we could clip the values to remove those people who are not, who are 75 years or above, because we don't want that. So let's go back to our clip values. We can find clip here. And this time we don't have the column that we don't want anymore. So this time, what we want to do is include age in here. So we want to include age. Once we've done that, we want to say the constant value for the upper threshold is 75. So what we can do now is have a look at running our experiment and see how that works. So now we can look at the output of clip values, and you can see that here. And then we can visualize the data. So this time, we see we still have 32,561 rows. And the age, we see here. Instead of seeing rows that are over 75, the maximum is actually set to 75 at this point, not 90 as it was previously. So we've clipped some of those results from our experiment, and that looks good because we're not sure why that's happened. So we've got our clip values and we have renamed our column. So why don't we have a look, and then we can work out which columns we would like to see next. We don't have to include all of them. So what we can do now is we can think about further cleaning the data. For example, we could look at looking at missing values. So we've already removed one of the columns, which we did not need, so that was good. But what we could do is think about cleaning the missing data that we do not want to see. So there is a module in here called Clean Missing Data. We've already tidied our data in some ways. We have removed the column we didn't want. We've clipped our values, so we only have people who are 75 years old or less. And now we can work on cleaning the missing data. And all we need to do now is take our modules and clip them together. So when we go to the Clean Missing Data task, what we can do is click on that, and we can see different ways that we could clean the data. For example, what we could do is remove an entire column if data is missing. We could remove an entire row. We could also generate missing values if we'd like to do that. So then what we can do is think about which particular cleaning method we'd like to use. So when we looked at our edit metadata and our summarized data here, we could visualize the data and we could see that some of the columns actually had data missing in them. So things like occupation, native country, and the working class. So what we could do is remove columns that do not have these items available to them. So what we can do in the clean missing data activity is simply remove the entire column if we do not need it. So let's test our experiment so far, and then we can see how it works. So now we've finished running our experiment. Let's have a look at the data. Now we can go to the visualize option. And what we see here is that we can see the number of rows, number of columns, and we looked at removing rows where data is missing. So what we could do instead is run another descriptive statistics model in here. And then that will tell us how many rows, if any, have been moved. So we can run this experiment again, and that will help us to understand what we can do in order to remove the data. So now when we summarize the data and go to visualize, we can see that we don't have any missing data now. Any columns, any rows, whereas one of the data items, one or more data items is missing, we have no missing data now. So that allows us to be more confident that our data is correct. So we summarized our data. And I'm going to tidy up this experiment so it looks a bit better. So we'll leave the summarized data items here. And then that way they're out the way. Over here. The next step that we might like to do is to try and think about how we can format the data. For example, if we like, we could format the data so it appears in a different format. For example, it's in a data set at the moment, and we could output that data. So the other thing we could think about doing is training the data that we have in order to understand it a bit better. So to do that, let's look up the train models component. What the train model component is going to do, it's going to take our data and it's going to use it in order to train a model. And then we can understand better what the model looks like when it is being trained and tested and deployed. So, but before we do that, we will need to split the data into a test dataset and a training dataset. So what we will do now is we will add a splits data component. And what we can do is connect up the first module here to the splits data component here. You'll notice that models like this can be connected to more than one item at a time. So we've got the clean missing data, and then we can split the data into a training and a test set. So that means often we use 70% of the data for a training data set, and then we test it with the remaining 30%. So let's sort out our data so that we can have two data sets, one for training the model and the other for testing the model. So let's take a look. What we can do is move train model over here. Then we can connect splits data to the train model. Now, when we click on splits data, it's going to say that 50% or 0.5 of the data will go to the training dataset and the remaining 50% will go to the test dataset. So we can see the 50% or the 0.5 specified here. So what we'd like to do instead is set that to 0.7, and that will work for 70%. So now 70% of our data will go to the train model module, and we'll reserve the remaining 30% for testing the model. So first of all, we need to identify which column it is that we are trying to predict. So let's go for the launch column selector, and we want to include the column names, which are called income. So we are trying to predict which column to use. We know which column to use. We want to predict whether people have above or below $50,000 a year. So we're going to include the column names and the income level here. And that is what we are going to use in order to train our model. So we can see we've got our column name selected here, but we haven't chosen which type of model we would like to use yet. So what we could do is we could use one of the regression classes. So what we could do here is you can see there's a range to choose from. So we could use one of the boosted decision tree regressions, and we'll see how that looks with our data. We could use more than one. But for the purpose of the demonstration, we're just going to use one model here. So now to train our model, you can see we've got our model here, and we have got our training dataset here. So now we can click on the train model item. Once we train our model, what we do need to do is to score that model. And here we've got the scoring mechanism here. Now what we need to do when we train a model is compare our trained model output with the testing data that we reserved from the splits data model. And you can see that here. So what we see instead is that we are using our test dataset, which is coming out the second pipeline here, and that matches with our test dataset, and our training dataset goes here. So what we need to do then is we can run our experiment, but it would be good to understand how well our model performs. So to do that, we can use an item which is here called the evaluate model. And what that's going to do is going to identify how well our model has performed. So it's going to give us the metrics that will help us to understand a bit better if our model is a good fit, or for example, it's not a good fit and we have to find a different way of assessing our model. We could try different models and see how they perform and compare them against each other. Okay, so now just to summarize before we execute the experiment, we've got our adults data set, we've got our metadata, we've clipped our values, so we have excluded data where somebody is 75 years old or below. We include that data, but if someone is about 76 and above, then we don't include their data. We also remove rows where the data is missing. There are different approaches to working with cleaning our data, but what we are going to do is we are just going to remove those rows for now. Once we've had a look at that, we then split our data into a training data set and a test data set. And you can see that here. Now we've got an opportunity to train our model, and to do that, we take our training data set, which is specified here, and we train it using our model. In this example, and we can train that model, and then we get scores for that. And then we've got the evaluate model, which tells us how well our model has performed. So let's run our experiment and we'll see how that goes. So this should not take very long in order to run. And then what we will do is we will then go back and revise some of the content that you need to know for the DP-100 exam for Microsoft. So we can see our experiment is nearly finished running. When the module is executed, we can see we have the green tick. And one important thing to note is we have written all of this experiment without writing a single line of code. Azure ML is the original low-code, no-code solution that allows us to create experiments in Azure machine learning and data science without having a coding background. For the exam, it's good to get practice using Azure machine learning. And to do that, you can sign up over at the website. So now our experiment is completed. So let's have a look at how well the model did. So to do that, we can click on the score model item, and then we can visualize it. So what we see here is our data, and then we've got the scores labeled. So this indicates whether somebody did or did not earn above or below 50%. So we can see here the probability if somebody earned over 50%. And here we see some probability where it was really the results weren't very clear. We see over 50k here, that's 1.0. So we can see it starts to give us some results in understanding better the likelihood or the probability of a particular school's label. So what does this mean actually? So let's have a look at how we can evaluate the model. So to do that, we go to the Evaluate Model module, and then we can visualize the data. So we can start to see here some of the metrics involved for understanding how well our model performed. So when we look at the data, we can see that the R figure, for example, is quite low, and the coefficient of determination is quite low. So the model is not performing very well. So what we could do is run the experiment again. This time we could use a different model. So to do that, we would just remove that model there. Then what we could do is look for a different model. For example, we could try the same using a multi-class logistic regression, and then we could run our experiment again. So if you would like to know more about how to choose which models to build, one thing to look at is the Azure Machine Learning cheat sheet. And I'll just display that on the screen just now so you can see it. This is a resource that's available in Azure. And what this does do is it gives you the ability to decide which algorithm you would like to use. So you can see here that there is a cheat sheet which looks like a flow chart. And you can download this from the Microsoft website. And I suggest that you keep an eye on it because Microsoft are adding new things in all the time. So what that means is we have got the ability to decide based on our business question what the machine learning model is that we will decide to use. For example, if we would like to predict between several categories, we could use one of the multi-class outputs. At the moment, we've switched to using the multi-class logistic regression, so we could use that one. If we want to predict values, we could use one of the regression types here. So in our last example, we used the decision forest regression. We then decided we would use another particular example of a model. So we can let that run. But please be sure to check out the cheat sheet, and then that should help you to think exactly the models that you would like to use. So when we evaluate this model, for example, you see this time that the overall accuracy is much higher with this particular example. So we also see the confusion matrix here. So the percentages are looking good. So that's a good example of where we've taken a situation which has used one model. We've then improved it by using another. So now we've had a quick whiz tour of using Azure Machine Learning. Let's have a look at some of the content that you need to know for the exam. For the exam, we recommend that you look at Azure Machine Learning. And that's something that you can keep looking at and reviewing and practicing with it. It has a good facility for learning how to use it. So you could use the 8-hour free trial, for example. It's a great way of getting familiar with the settings, the models, and the different ways that we can deploy the experiment. So what you can do is you can set up an Azure machine learning resource via the Azure portal as well. And to do that, you need an Azure account, and then you can create a resource. So in order to set up the workspace using Azure, you need a number of subscription items. For example, what you do need is the workspace name. You need to give it a name. You need an Azure subscription, the resource group. You need to know the location and also the workspace edition of what you are going to use. So if you'd like to do some further reading, we have some references here. Basically, there's great references over at the Microsoft website. So now what we're going to do is learn a bit more about creating, configuring, and managing Azure machine learning workspaces. So you can access data in different ways using Azure machine learning. What you could do is set up access to the data using an Azure machine learning dataset. Or you could consume the data in the automated machine learning experiment runs, and in the latest version of Azure machine learning, you can set up dataset monitors that will track how the data has changed from over time. For example, we're aware and very familiar with the fact that data changes over time. It lives in a very fluid and dynamic environment. So with that in mind, you can set up dataset monitors to help you to track data drift. Okay. So what we can do now is we can think about what data objects actually look like. Because data sets, for example, allow us to reuse data with one reference. If the data source is pretty large, then it's not a trivial task to copy and change data sets all the time. What we can do is reuse the data sets in Azure and use that as part of different experiments. The data sets, for example, can mean that we can look at whether the data is a tabular data set or whether it's just pretty much a file data set that needs a structure or a lens put on it. So that's one thing to think about, is what does the data actually look like? Because that will help you to identify if you need to do more data processing than you'd originally thought. So when we look at this in Azure Machine Learning, the first thing we do is we can sign into the workspace. In this particular example, we have set up a preview and sit here, and you can see how the data looks in Azure Machine Learning. And we've just set up just a few example screenshots so you can have a look at that. So the first thing we need to do is create a data store. And we can do that using Azure Machine Learning, and we can create a data set from the data store. So in the preview edition of Azure Machine Learning, we need to use the data store in order to store our data. And normally that can be Azure Blob Storage. And once you've stored your CSV files, for example, there, you can use those to create a data set which points at the data in your data store. You also need to think about how you can access the data in your data store. For example, if you're using blob storage, like we are here, what you can do is have a think about how you access that data. So in this particular example, we are connecting to the blob container using an account key. And you can see where the account key has been copied and pasted. You can also set up settings and preview the data as well. That will help you to be confident that the dataset has been understood. Here you can see column headers, and you can identify the encoding of whether you need to skip rows at the top of the page, for example. And in this example, we can see that we are going to store all of the data. We are going to include it all apart from the path to the data itself. So here's the data set from a data store. You can see the name of the data set. In this example, it's DP-100. And then you can see when it was created and who created it, which was me, and it is a tabular data set. So that's what the data set looks like when it's been created. If you're using the Azure Machine Learning SDK for Python, then you can also create data stores and data sets using code. And here's some examples of the code here. In the first line of code, you can see we are importing data from Azure ML. We are using the Azure ML core class to import other objects such as workspace, the data store object, and the dataset. We're also ingesting a data store, which is called DP-100 data store. You can also see that the existing workspace is assigned to the variable called workspace for readability, and we are ingesting the workspace configuration from the workspace itself. Once we have that information, we can retrieve an existing data store using its name. So it's always important to give the variables a good name. And just to be clear, here is the code itself. We are ingesting data from Azure ML Core, and we're importing these classes. For the DP-100 exam, it's important to be familiar with Azure ML Core and its classes. So you need to have a look at the examples that Microsoft have put up online. You can see that we are referring to a specific workspace, and we can see the data store name down the bottom. So here's another example where we are using the dataset and the Python SDK. We are accessing the Azure Machine Learning service using Python, and that means we can interact with the Azure Machine Learning service using standard Python code, as long as we call the Azure ML Core class in order to do it. So here we have the data store path, and we have given the dataset a name, which is called myDataset_ds. Here's another example where we can create a dataset using the Python SDK. In this example, we are creating a tabular dataset, and we're doing that via a path in the data store. So what you can see is the data store has got CSV files in it, and we are using those in order to view our data. So we can also interact with the data using the Python SDK for Azure ML. In this example, we are using a Python code to specify that the data is displayed in a Python data frame. So you can see that the Python data frame is displayed on the right-hand side of the screen. The code itself is displayed slightly above it. And you can see the myDataset.ds variable has got the instruction after it to send the data to a data frame. So this should be familiar to people who are comfortable with Python. So we can create datasets using the Azure ML SDK for Python. This is a preview edition, and what we see here is that we can generate sample Python code from the Azure ML interface. To do that, we can go to Datasets, and we can see the ability to consume the dataset is there. It's in the top third of the page, and it's in the middle here. It's underlined with blue. And you can see the sample usage is set out here. You can see the workspace and the dataset are being imported in the first line of code underneath the comments. The comments themselves are written in green, and the first line of code itself is ingesting the service from Azure ML Core. So I recommend that you have a look through the classes for Azure Machine Learning. It will set you up very well for the exam. So here we see an example of a subscription ID, a resource group, and a workspace name. And once those variables are set and they are collected together in a workspace, we can then call that dataset using Python code. This is enormously useful for data scientists who are accustomed to using Python and want to really use the power of the cloud in order to have a think about expanding out their use of the data from local datasets to much larger cloud-based datasets. So just in case you need to see the code again, here is a similar example. In this example, we set up a tabular dataset, and the dataset in question is a SQL database, and you can see it's specified in the SQL data store here. It's using an object called datastore, and it's using the method get. And to get the SQL data store, it needs to know the workspace name, and it also needs to know what the data store actually is. In this example, the data store is set to AdventureWorks LT, which is one of Microsoft's sample databases. You can see the SQL dataset here. The tabular dataset is retrieved from a SQL query, and you can see the SQL query in the very bottom line. Here's another example where we can connect to our dataset. We have our subscription ID, resource group, and a workspace name. And now we have got the workspace and the dataset details there. Then we can download the data from the dataset if we want to do that too. We can also create a file dataset using the Python SDK. We can set up the Azure ML Core, and we can do that to import the workspace and the dataset. We have the details as previously, including the subscription ID, and then we can put everything together. The workspace details, and then that means we can retrieve the dataset details. We can also create a file dataset from a public repository. So here's an example where we are retrieving data from a GitHub repository. And then we can assign that data to a variable. In this example, the variable is called OECD dataset. And here's some examples of further reading in case you would like to zone in on that particular topic. So now we are going to have a think about how we can run experiments and train models using Azure Machine Learning. So we have a number of models that we talk about when we are setting up data science. Now, people's understanding of a model is different depending on their background. Some may see it as more a mathematical concept, and you can see the Merriam-Webster dictionary definition here. In data science itself, we can use a model and we can perceive that as a lens or a structure in order to understand the data set. The model itself requires training in order to find patterns in the data. So in the adult census dataset example that we had, we gave it some data and then we analysed that data using various models. And basically, they form a lens or a pattern over the data in order to understand it better, then hopefully use it for prediction as well. Here's a good example of a model here. The model is said to learn from an experience E with respect to a class of tasks depicted as T and the performance measure P if its performance at the tasks as measured by the performance improves with experience. So at its lowest level, this is what data science modelling is trying to do. So a key concept in Azure Machine Learning and in the DP-100 exam is the concept of a pipeline. A pipeline is a workflow of machine learning tasks, and they are executed as part of an overall experiment. So we can have the case where each activity is placed into a step, and then we can run all of those steps in parallel or serially, if you like. If you are working with big data sources, it's very often very useful to have them running in parallel because you may have an awful lot of data. You can also use different compute targets throughout the chain. What that means is you can use different technical apparatus in order to provide you with the specific compute that you need in order to run the experiment. For example, if you are just developing on a small amount of data, then you may not need a very powerful compute target. However, if you are working with terabytes of data, then you may find it easier to work with data that's already located in the cloud because your laptop may not hold all of that data, for example. So Azure Machine Learning Designer is something that we had a quick look at in our demo. We could set that up to be a drag and drop tool and set it up in order to really make a difference to our business by offering machine learning in a low-code / no-code way. Currently, the code is in preview, so you need to watch out for that being GA. For the exam, you will probably find that the classic modules are not that different from the preview modules. It's always good to get practice in both so that you can do really well in the exam. So the next step is to think about how we can make our pipelines so that they can ingest data, how they can be trained to use models that are efficient, and how those models can be deployed. So before we get started, what is a module? Well, we looked at plenty of those when we were building our experiment in Azure Machine Learning. We saw that modules are basically building blocks for creating experiments. The modules basically encapsulate a function, and underneath the module itself lies a little bit of code that interacts with our data in our Azure Machine Learning workspace. Modules can work together in order to share data, to modify the data, and output the results. And they do interact with one another. In Azure Machine Learning example that we saw, we could pass data from one module to another, and we could do that without having to write any code. So we have plenty of examples of designer modules, and those implement segments of code such as clipping values, changing columns, removing missing data, and even deploying our models. So all of these models together all do something independently that can contribute to the overall experiment in Azure Machine Learning. So there are plenty of different modules in Azure Machine Learning. We can see the data preparation ones that we looked at earlier. Those help us to do statistics on our data in order to understand it better, and also to clean our data. For example, in our example, we use the clip values module in order to remove data where the person is over 75 years old. We can also use modules for building and evaluating models, and we saw that when we started to look at how we could score and evaluate our models. So we also have the ability to change the format of our data. For example, if the data comes in as text, you may need to change that data so it comes in a number format. We can also think about transforming our data. For example, we may have to scale our data so that it fits between a pattern of 0 to 1, or we may need to normalize that data. And we need to do that in order to make sure that our data is not biased or has reduced bias in it. We also need to think about the characteristics in our data that contribute towards effective experiment building. We can also use custom code modules in our designer. So far, we have looked at Azure Machine Learning, and we have looked at the pre-built models available. So the custom code modules are available in R and in Python. We can add in custom R codes to an experiment, and we can also look at Python modules as well. And those allow us to add in custom Python code to our experiment. That includes key Python packages, such as NumPy, SciPy, and scikit-learn. We have the Create Python Model module, and it's used to create an untrained model from a Python script. So you can use that. If you're already comfortable using Python, you can bring your Python skills to the Azure Machine Learning table. That will really help you to adopt Azure Machine Learning. And it will also help your skills in learning the technology in order to pass the exam. So you can create Python modules in Azure Machine Learning, and if the particular Python package is not available to you, what you can do is import them, and you can use pip in order to install them. So there are plenty of opportunities for you to add new Python libraries, new Python learners to the Azure Machine Learning experiments that you are using. We can also execute Python scripts. Python is available in different distributions, but the Azure Machine Learning distribution uses Anaconda, and that's a fairly common way of processing data using Python. It will also accept data in different formats, such as data in zip files. And it will also output data in the Python devices, and those can be stored in Azure Blob Storage as well. So we can also debug our Python code. If the code is not working, remember to check for indentation errors, very easily done when we're using Python, and also check out to see if there are any white space errors as well. So there are some limitations to Python in Azure Machine Learning. And we can copy and unpack the zip file in Azure Machine Learning. But when we do that, it can consume lots of memory. So we can also use Pickle in order to serialize our objects, and that helps us to download our models, for example. These are good terms to know when you're thinking about the exam. So make sure and get some practice in using the Azure Machine Learning Designer and have a look at the outputs as well. So let's have a look at how we can run training scripts in Azure Machine Learning. When we run training scripts in Azure Machine Learning, we can do that using the Azure Machine Learning SDK. We can also use the Azure Machine Learning SDK to consume data from a data store. And we can also do that using the Python SDK to set up and consume data from a data set. The data sets are made available through the data store. We can also choose an estimator. An estimator is a way in which we can choose pre-configured encapsulated pieces of code that will help us to build neater, tidier, and more efficient code in Python using the Azure Machine Learning workspace. We can also create and run experiments. An experiment is a grouping of executions, and experiments belong in a workspace. Developers can actually create experiments in the Azure Machine Learning experiment class as well, using the Azure Machine Learning Python SDK. And for developers, that means that your code is reusable, and you could then use that across different experiments and use that across different multiple compute environments. If you need to execute your data science experiments at speed, and you have a number of compute environments in order to do that, you could reuse your scripts. You could also reuse them for moving your data science towards a life cycle, which is closer to a software engineering life cycle. Using data in the development, a test and a deployment environment while you're getting your experiments up and running. So there are plenty of ways in which scripting can help you to automate as many activities as possible. And when you do that, that means that you are able to free up time later. It's usually a good investment of time in order to do that. So in Azure Machine Learning, a key concept is a script run configuration. So basically that is made up of a script-based experiment, and that will run the machine learning model for you. So the code for these can come pretty expensive in terms of code to write, and they can be quite complex. The idea of the estimator is to simplify this as much as possible. So let's take a look at the estimator. Estimators are available to consume data from a data store like any other Python code. You can see here that we can actually consume data using an estimator in Azure Machine Learning, and we can use a variety of storage types here. We have blob storage, file share, and we have both generations of the Azure Data Lake storage We can also retrieve data from the Azure SQL database, and we can even use Azure Postgres as well if we like. So there are plenty of ways to make use of your data in Azure Machine Learning. It's no longer the case that people see Azure like a large USB stick in the sky that would look after their data for them. Instead, what we see now is people want to do things with their data. And in Azure Machine Learning, the underlying data storage mechanism does not matter too much. The main thing is that we have access to the data, and then we can work with that data, we can shape it and prepare it, and then do important and insightful things with our data when we are creating models. So we can consume data from datasets in an experiment, and we already looked at tabular and file datasets earlier. So we can also consume data, which is in a big data file format, as well as more common row and columnar formats. And we can use the Python SDK with Azure Machine Learning in order to access those datasets. So there's a few things when we want to think about moving to Azure Machine Learning. We need to think about where our data is stored. We also don't want to think about running our experiments on our hard drive, because we can see so much more data in the cloud. So if our data is starting to become too big for virtual disks, for example, we could use a different framework such as Apache Spark and use Databricks in order to really make the use of much larger data sources, or you could use technology such as Dask, and it will help you to perform processing the data out of memory. It will swap the data in and out again, and that will help you to make the most of processing the data. So in terms of the estimator, what does this mean? The estimator overall makes our Python code appear so much more easy to read. It also means we can have our run configuration and our strips configuration in a single object. That means that our code is much tidier to read. We can also find predefined estimators, and that allows us to use very specific frameworks in Python. For example, we could use an estimator which is already pre-built with the scikit-learn packages, for example, and it would already have references to the libraries that we need, and that would give us a good start because it means we would not have to go and call them for ourselves. They would be available as part of the estimator. We can also use PyTorch and TensorFlow as well. So even though TensorFlow is backed by Google technology, we can still use it in Azure. So there are plenty of opportunities for us to be really insightful in the way that we approach our data. So there's plenty of things that we can do. So far we've had a good look through Azure Machine Learning, we've had a look at a demo, and we've had a look at different ways we can ingest our data and how we can actually see how our code could be made more tidy by using the Python SDK with Azure Machine Learning and using an estimator in order to work with our code to make it much easier to read. It also helps our scripting efforts. So in the next topic, we're going to explore Azure Machine Learning SDK in more detail. So we can create and run experiments in the Azure Machine Learning interface, and we can also do that in the Azure SDK for Python. So we can make our code less complex by using the estimator. So that's always handy because the codes can become very complex. And we can also automate our as well. So, oh, sorry, I've skipped through some slides, so just go through these. So I went back through some slides, so let's have a look. Okay, so here is how we can train with estimators. The first thing we need to do is create a compute target, and that's going to work as the engine that's going to run our experiment. Then what we need to do is upload the training data to the data store in Azure Machine Learning. Once we have done that, we can create a training script, and then we can use our estimator objects, and then we can submit the estimator with all of our details so it can be run. So here's an example of the estimator class. This is a key topic for the DP-100 exam, and it's strongly recommended you become very familiar with the estimator and code samples. Estimators are a great way of simplifying your code, and it's well worth becoming familiar with them, even if you do not intend to sit the DP-100 exam. So here's an example of the code. In the first part of the code, we can create an estimator. In this example, we are creating an estimator using the estimator keyword here, and we've set it up with a number of details. For example, you can see the source directory is set to the experiment folder. You can also see the entry script, and that's named as the run script pi. We can also see the compute target, which is set to local, and it's also importing conda packages from scikit-learn. The second part of code is about creating and running the experiment. And what you see here is that we have the experiment, which uses the workspace, which is set to the variable WS, and the experiment name is called Online Shopping Experiment. We can then run the experiment and submit it with the configuration that we see here, which is set to be the estimator configuration. So the code itself is very readable, and it's a good way to become familiar with deploying and running our experiments using the Azure Machine Learning SDK for Python. We can also review different framework-specific estimators. These are also designed to make our code more simple. For example, the top one is very similar. We have seen this one, where we can set up the experiment, we can run the script, and then set up the compute target. This one is a sklearn estimator. In the last example, that was just a generic estimator, and you can see that in the second line of code here. But this particular estimator is actually using sklearn, so it's got one line of code less. Because we're using the sklearn estimator, you don't have to specify again that we are using the sk scikit package. And that's what we see here. In the fourth line, we have to specify directly that we are using scikit-learn. But then when we look at the sklearn estimator, we can see explicitly that the fourth line is gone, and the first line of code refers to sklearn. So that is one of the estimators that are available to us. In the bottom piece of code, you can see that the estimator code is the same. What we have is the experiment is set to the estimator variable, and all of that information is then submitted to the Azure Machine Learning SDK for Python, where the experiment is executed. You can see here it's possible to add additional script arguments to an estimator. So now we are looking at the Scikit Learn estimator again. In the third and fourth line of codes, identify additional script parameters that have been set up. In this example, you can see the regularization rate, and you can also see the compute target as well, which is set to local. Then, as before, we can create and run the experiment by calling the estimator variable. So once we are able to write up this code, it becomes very easy to change it in order to meet our requirements. And that's good because it also means that we can develop our code and we can script it, and then that allows us to automate it. So here's a quick summary of estimators. They allow us to simplify our code because they are already preloaded with configuration information that might be useful to us, such as whether it's using scikit-learn or whether it's using another type of Python library. For example, we could be using an estimator which already has TensorFlow in place. We can also parallelize estimators as well, so that will allow us to make them run even faster. So, to summarize, we have looked at how we can create and run an experiment, how we can consume data, and we've also had a look at estimators in more detail as well. Estimators are very handy for allowing us to streamline our code. So now we have some more examples where we can run experiments and train models. When we're doing that, we need to consider how we can generate metrics from an experiment run. We can do that using Azure Monitor and Azure Machine Learning. We also need to consider the difference between metrics and logs. Metrics can help us understand how our data's performance is working right now, but log files give us a view of history over time. So here is Azure Monitor, and here are some examples of the types of data that you can use. For example, you could examine how you can monitor your application, and you could also consider your subscription if you are perhaps needing to add in additional resources. You could also have an eye on that using Azure Monitor, and you could also work out how you can communicate the monitoring issues to other people by generating reports. Log files can also help you to troubleshoot critical issues. For example, if you are running out of storage space. You can also use Power BI in order to view the data more clearly, and you can see how that's set up. And you can also access the log file data using Power BI as well. That allows you to communicate any resource issues much more clearly to people who need to understand that better. You can also set up alerts. For example, for some reason, if your model fails to deploy, you can have an alert set up. That alert will be able to email you to let you know that there has been a failed deployment. So there are plenty of opportunities for you to review how you can set up alerts that will help you to make your Azure machine learning solutions work more effectively. So let's have a look at how we can retrieve and view experiment outputs. To do that, we need to review the compute targets and we can also review input files as well. We can also review inputs to the experiments themselves. To do that, Azure Machine Learning must have access to the Azure Machine Learning data store. So that's a key point in order to pick up the data. After all, if we don't have any data, then we don't have any experiments. So we must be absolutely sure that we will be able to get the data when we need it. Here's an example of what log analytics look like. We can use a language called Custo in order to look at compute job events. And the query could look like this. In Custo, we can use the pipe as filters. So here we are reviewing the AML compute job event, and we are filtering that data to the points where the job ID is equal to the figures that we see here. And then we can specify exactly which columns we would like to see. So in this section, we have reviewed how we can see log metrics in Azure Machine Learning, and we can also review experiment outputs, and we've had a look at how we can use logs and Custo to troubleshoot experiment runs. So then, in the final section, we are going to have a look at how we can automate the model training process. In this section, we will examine how we can automate Azure Machine Learning. We can do that using the Azure Machine Learning Designer or the Azure Machine Learning SDK for Python. So we can create a pipeline using the Azure Machine Learning SDK for Python. To do that, we can set up pipelines which we then publish to the Azure Machine Learning workspace. We can use those pipelines for a number of things. For example, we can use them for batch scoring scenarios. For example, in our example earlier, we used some data to understand better whether people had the ability to earn above or below $50,000. We could use batch scoring in that example. And we could do that by giving it the adult census data in a batch format, and then we could then examine the results. We can also reuse steps in pipelines. They don't have to stay just within a particular experiment. We can reuse those steps and parallelize it in the same experiment. And that allows us to have experiments in Azure Machine Learning which run more effectively. So here's some examples of some code that will help us to understand how we can do just that. The first step, as always, is that we can ingest the Azure Machine Learning Service using the Azure ML Core class. Once we do that, we can set up the configuration from the workspace, and we assign it to a variable which is called WS. And this is using Azure Machine Learning SDK for Python in order to connect to the workspace. You can see we have connected to the workspace and data store classes, and those are available from the Azure ML Core. Once we have done that, we've set up the resources to run a machine learning pipeline. We set up a data store. We set up a data reference object in order to point to the data. And then we can set up the compute targets that the pipeline will run on. And we can do all of that in the Azure Machine Learning SDK for Python. So how do we pass data between the steps in a pipeline. Let's have a look at how we can do that in Azure Machine Learning using the SDK for Python. So when we collect the pipeline, we need to understand which data we are looking at, and we need to understand which workspace the data is in. The data store is stored in the individual workspace. Then when we create the workspace, we can attach that storage to it. And here's some example of the code. What we can do is check out the blob storage data name. And you can see here, we have given it the name DP-100 blob SDK. And that's the name of the data store that we can use. Once we've done that, we can also specify the container name, which stores our data. When we set up our blob storage, we can set up different containers as we need. We can also set up the account name for the blob storage, so we can access that. And we can also set up the account key as well in order to access the data. Once we've done that, we can upload files to the data store, still using the Azure Machine Learning SDK for Python. You can see the first line of code sets up the blob data store details. Once we have the data store name, the container name, the account name, and the key name, we can put those pieces of code together in order to access the blob data store. We don't have to just deploy datasets to the data store. We can also upload files as well. And here's an example where we can upload files such as a model file. So you can see the pickle file just here. You can also output data as well. So in this example, you could use the dataset and place data back into the blob storage. In this example, we are using the diamonds dataset, and we are going to output that data to the data store, and we also specify that it has a name. So how do we run a pipeline using Azure Machine Learning? So let's have a look. So now we can run a pipeline. Again, we need to use the Azure ML Core SDK, and we can import the experiment class. Once we have done that, we can submit the pipeline to be run. Here, we've given the pipeline run name as pipeline_run number 1. The experiment is going to run on the WS workspace that was set earlier. And once we have done that, we can then execute the models experiment. So that's the name of the experiment. And once we've done that, we can submit it, and we just simply wait for the experiments to complete. So once we have run our pipeline, how can we possibly monitor that run? It turns out it's not that difficult. We can use the Azure Machine Learning Designer in order to do that. For example, we can monitor the pipeline runs here. So what we do is we wait for completion, but we can use the run details command in order to show detailed information about the execution of your experiment. To do that, you need to import data using Azure ML widgets. And when you do that, you can then use the Run Details widget in order to display information that you require. It's in a much more readable format. If you look for the GitHub repository for Azure Machine Learning, which I will show you in a moment, then that will help you to become very familiar with the data that is output by Azure Machine Learning. So what we will do now is we'll have a quick summary, and then I'm going to point you to some additional resources so that you can use those in your studies. So one thing to look at is the Azure Machine Learning GitHub repository for DP-100. So in case you've never seen it before, please do check this out. It will really help you when you are trying to do your revision. It really makes things much easier if you have tried to run through some of the code. There are plenty of examples here of the concepts that we've been talking about. For example, if you're interested in trying out data drift, you can look at the code here, and you can see some of the codes in action. For example, in this piece of code, we can import the workspace using Azure ML Core. You can also use a baseline dataset, and then we need another dataset to compare it with. First of all, we create our baseline dataset, and we register it. And then we can generate simulated data as a practice, for example, and that will allow us to compare our original dataset with some simulated datasets. So that's quite an interesting activity to do as well. So once you've reviewed the code, you can start to understand better how that works, and that will really help you in the DP-100 exam. Once you've set up your datasets, you are able then to set up a compute target in order to execute the comparison on. You can see here some of the classes are very key and they're used again and again. It's recommended that you become very familiar with them for the Azure Machine Learning exam. You can see some of the classes here. For example, you can use the Azure ML data drift in order to import the data drift detector. So there are plenty of different ways that you can become really familiar with the code so you understand it better for the exam. We just spoke about the Run Details widget briefly, and here you can see an example of the code. So that will help you to understand the output so much better. If you want to learn more about how to detect data drift, there are plenty of great resources on the Azure Machine Learning website, so please do check that out. Remember also to check out the Azure Machine Learning cheat sheet. That will really help you to understand which models you need to use for Azure Machine Learning. So, as a quick summary, we have reviewed plenty of items for the DP-100 exam. We have reviewed how you can ingest data, how you can create pipelines, and how you can create experiments using the Azure Machine Learning SDK for Python. We've also had a look at how you can run pipelines and how you can monitor them as well. So with that in mind, It just remains for me to say thank you for attending this session on the DP-100 exam. My name is Jen Stirrup, and it's been my pleasure to speak with you today. If you have any questions, I'll be happy to take those now. Okay. I'm just going to check to see if there are any questions. Okay, so I don't see any questions, but I just want to say a personal thank you for joining. Please check out my profile on the Skill Me Up community learning page. You'll be sure to find me there, and I look forward to hearing from you. I just have one request. When you pass the exam, please do get in touch to let us know. I love hearing from students who have passed the exam. So when you pass and you want to share the good news with someone, please do let us know. Thank you very much.